Okay, on the last video, we had come to the point where we were saying that the liver sends out VLDL, makes VLDL. The VLDL mainly carries triglycerides, but it takes cholesterol too. The liver sends that out, it's in the circulation. When it runs across endothelial cells in adipose tissue, cardiac and skeletal muscle, they produce this enzyme, lipoprotein lipase, that dissolves some of the VLDL. That allows some of the cholesterol to exit from the VLDL, leak through the blood vessel, the capillary wall, into these cells, adipose, cardiac muscle, and skeletal muscle. The cardiac muscle, skeletal muscle use this triglycerides as energy. The adipose stores this material. Okay. All right. Now, I brought up need insulin. We won't get into that. All right. What happens now then is this. When you suck some of the triglyceride out, let's think of it percentage-wise, and you don't really do anything with this, then you would reshift the percentages simply by sucking some of the triglyceride out. Okay. When that occurs, the protein amount and the percentages of all these others will increase too. So we go then to something I'm going to call LDL. Now see, here's 25% protein. Let's go back. See, 5 to 10%. But what did you do? You came in and you took a lot of the triglycerides out. So everything else shifted up percentage-wise because you dropped this percentage. You still need 100%. All right. So now we're at something called low-density lipoprotein. Now look what's the big boy in this, cholesterol. Well, this is cholesterol that was carried away from the liver because the LDL, low-density lipoprotein, was formed as a result of sucking the triglycerides out of the VLDL. But the VLDL was sent out from the liver. So therefore, this carries cholesterol to cells that need cholesterol. What cells need cholesterol? Every cell in the body. Every cell in the body needs cholesterol. Okay? Some need it more than others. So let's go to this slide. Okay. Low-density lipoprotein primarily carries cholesterol. Okay, it circulates into... Now, here's where the difference is going to be. Unlike with the chylomicron and the VLDL, we're using enzymes in skeletal muscle, cardiac muscle, adipose to dissolve out the substance. This doesn't do that. For the LDL, you have LDL receptors on cells. LDL receptors. Every cell in the body forms LDL receptors in that every cell in the body needs cholesterol. Some cells, such as those forming the steroid hormones, because remember, cholesterol is the precursor for all that, need more receptors. It's like they have more antennas for it. The amount of receptors placed in the cell membrane is under the control of homeostasis. Okay? Now, what will happen is then, every cell in the body will take its cholesterol. It will take its cholesterol. And then whatever's left over from the LDL can go to the liver. Okay? The LDL, ANP1, the LDL and its lipid are taken in by receptor-mediated endocytosis. Check that out in ANP1. The cell then performs endocytosis. Okay? So that's how you get cholesterol, these LDL receptors. These LDL receptors. I'm going to bring this back up in a little while here when we talk about pathophys. Okay? All right. Let's go a little further. LDL, now we're going to HDL. Okay? Now HDL, listen to what I'm going to say. HDL is a carrier protein made by the liver and sent out independently. Sent out independently. Is not a part of the conversion process of this. It is produced independently by the liver. and a little bit by intestinal cells, but primarily by the liver. It functions to scoop up and transport excess cholesterol. Now, cholesterol that got lost along the way, so it doesn't cause atherosclerosis, is being scooped up and carried back to the liver. Carried back. So it's a scavenger carried back to the liver. So it doesn't clog up your blood vessels. See, it's high density because look, a big protein amount. Scoop up. So that's why they'll oftentimes call HDL your good cholesterol. It's really not cholesterol. It's a lipoprotein. That's a street term, good cholesterol. You know, people don't understand all this stuff. Somebody, unless they took a course or very astute in this. So you have to give the words bad cholesterol and good cholesterol. You have to give the words bad cholesterol, which is really not cholesterol, the low density, and good cholesterol. But its job is to scavenge. Okay? So then when we look at this, and we put it all together there, you can see, we'll move this over a little bit here, that over, so we can make this a little bigger. You can see here that if you look at this, it's kind of composite. So the liver synthesizes cholesterol, okay? So in other words, where is most of your cholesterol made? Remember we talked about that HMG-CoA reductase? The liver is where most of your cholesterol is made and transported. It's also where most of it comes if you eat it in the diet. It's stored in here. So the liver. That's why when you take statin drugs, they said one of the things is it can mess with the liver because that's where you're primarily making it. But anyway, let's go further. So the liver makes VLDL, then it would have converted to IDL, which I didn't talk about. Then it would have converted to LDL. The VLDL, again, carries primarily triglycerides. It has a whole lot of triglycerides in there. But once you suck the triglycerides, first you go to IDL. We won't get into that. But ultimately LDL. And if you recall, the LDL had more protein, but you sucked out triglycerides, so it was heavy in the liver thing. Now, the LDL then is carried to the rest of the body, okay, and you're using LDL receptors, and then whatever's left carried back to the liver. Then here's HDL over here, which is independently done. The scavenger, independent. It's a nice little setup to show you independently done and everything. Then remember the chylomicron, the intestinal epithelial cells. So you would have taken everything out of it, and whatever's left, the remnant goes here. So this kind of summarizes everything. I kind of like this slide here. This kind of summarizes everything. All right. Now let's go here. Here would be, if we were drawing your blood, desirable levels of all these. Here's your LDL, HDL, and so forth. Now, I want you to, let's draw attention. So what you'd like to have is cholesterol much lower than 200 milligrams per deciliter. Okay? LDL, right here, remember that's the one that primarily carries your cholesterol. Some call it the bad. You want to have it low. See, for LDL, you want to have it low because that's your bad cholesterol carrier, some will say. HDL, you want to have it high. Now, the only thing that exercise, particularly aerobic exercise, like swimming and running, do on lipid levels is to raise the HDL level. Because the more HDL, the better it is. Now, I want you to, let's look at this here. Total cholesterol to HDL ratio. Total cholesterol to HDL ratio. Now, let's say somebody had a high total cholesterol, but they also had a high HDL. See, that kind of masks it. So if a person had a high total cholesterol, but they increased their HDL, even though ideally you would like to bring this down, but the high density lipoprotein, the scavenger, could help you out. So that's why we do, when we draw blood, we do a total cholesterol to HDL ratio. Here, triglycerides, remember that was more associated with the VLDL. So this is kind of desired blood lipid levels. Okay. Now, let's say that you came in with a high cholesterol. Okay, let's think about this. And we did everything we could to try to bring it down, which means, I shouldn't say that. We first gave you a diet and said, okay, come back in 6 weeks or 8 weeks, use this diet, and let's see what your cholesterol. So let's say you started out with a 240. We'll just use that, a 240. You used the diet and you were a compliant patient. When you came back, you were 215. Now you are down, you're 215, but you're still higher than you should be, right? So in that case, we got to figure that you're making too much cholesterol inside, or your receptors aren't working. The LDL receptors are bad, both of which could be a genetic issue, both of which either making too much cholesterol or bad LDL receptors to get it out of the bloodstream, both of which could be a genetic situation. So what we have here in this is we have these things called the familial hyperlipidemias. The familial hyperlipidemias. Familial means genetic in the family. Hyperlipidemia means high level. And there are different kinds. Some are LDL problems, VLDL. So in other words, when we look at your blood, if somebody had a high triglyceride and we gave them a diet and they still was high, then we would say, oh, they have the type 4 hyperlipidemia. So this would be more of a genetic aspect. Now, what could we do about that? We can't change the genetics. So then what we could do is come in and give them some drugs, medication. One of the first drugs you give them could give is HMG-CoA reductase. Now that's a good one, because remember that blocks that enzyme. Here's where the problem is though. All medications have side effects. Listen to me. All medications have side effects. So where do you make cholesterol? In the liver. So what we do is to draw something called a liver panel. Now I kind of brought that up in another video. That's where we look at the isoenzymes. See, I brought that up in another one. So we do a liver panel to see how good your liver is already. If your liver shows a high isoenzyme level, which means you kind of have a little problem, then we have to go to another medication because we can't help you on one end and hurt you on the other. So anyway, but there are some other drugs we have too, but these are kind of the best ones. So that kind of gives you an idea of what we would do. We would do this if your diet alone could not bring the cholesterol down into a sufficient range. Okay? So that's where we are there. Okay? Then we have other bile acid sequestrants. A bile acid sequestrant would mean that if you did that, sequestered the bile acids, remember that's in bile, and that would keep you from absorbing. That means you'd have a lot of fatty stool though. So there are many differences. I'm not going to get into this. This is not a pharmacology course. I just wanted you to get the overall understanding of how this situation works there and so forth like that. All right. So we'll close on this one. And the next thing we want to talk about now is coronary artery disease. We want to kind of chat on that a moment in the next video. Okay? Thank you there.